Hi all. Today we're going to talk about how to graph the secant function, and we know that secant is the reciprocal of cosine. So I drew my unit circle out here, or at least a circle with all of our radian measures going around it, but I want you to notice that I started going this direction with positive angles, and then I went this direction with negative angles. And the reason I did that was because quadrant 1 and quadrant 4, cosine is positive. Quadrants 2 and quadrants 3, cosine is negative. So I can say plus or minus pi over 6 has a positive cosine, plus or minus pi over 4 has a positive cosine, so on and so forth. So in order for us to graph this, we need to find what our cosine value is. So I made a little chart, and the first column has our angles in it. The second column has our values for cosine. So to find the values for secant, all I did was I took the reciprocal of my cosine values and I created this column right here, this last column. So that's the column I'm going to graph. But before we graph that, I do want to point out that secant is undefined whenever cosine is 0. All right, so if the value of cosine, you plug in an angle and you get 0 for cosine, secant is undefined. And if we take a look at the angle that cosine is 0 at, it is pi over 2 or 3 pi over 2, or we can say negative pi over 2 going in a negative direction. So anytime that cosine is coterminal, right, you're taking the cosine of an angle that's coterminal with pi over 2 or 3 pi over 2, you're going to end up with an undefined value for secant. And when we have undefined values, what do we graph? We graph asymptotes. So the very first thing I'm going to do is I'm going to draw in my asymptotes for my secant function. All right, so I know at positive pi over 2, I have an asymptote. So I'm going to draw that in as a dashed line, and we always label this. And then I'm going to draw in negative pi over 2 or negative 90 degrees, which is coterminal with 3 pi over 2. And this is x equals negative pi over 2. All right, so what happens to our secant function in between here? All right, so at 0 degrees, cosine is 0 and secant is 0. Cosine is 1 and secant is 1. So I'm going to graph 1 here. At pi over 6 and negative pi over 6, we have a value of radical 3 over 2 for cosine. And that's when we take the reciprocal, approximately 1.2. And then for pi over 4, we have radical 2 over 2. When we take the reciprocal, it's about 1.4. And then at positive and negative pi over 2, we have a value of 1/2 for cosine, so secant is going to be 2. And I know as my graph approaches my asymptote, as my angle approaches pi over 2 and negative pi over 2, which are the values of my asymptote, my graph should approach but not touch my asymptote. So you can see it kind of looks like a parabola in between the asymptotes. So what happens outside of the asymptotes? Well, at positive and negative 2 pi over 3, if I look at my chart, I have a negative 1/2 value for cosine, so secant is negative 2 at these points. So let me plot that. And then at negative 3 pi over 4 and positive 3 pi over 4, I have a negative cosine value of negative radical 2 over 2, which is approximately negative 1.4. And then I have at positive and negative 5 pi over 6, a value of cosine that's negative radical 3 over 2. When I take the reciprocal, that's approximately negative 1.2. And at positive and negative pi, I have a value of cosine that's -1, so its reciprocal is also -1. So when I draw in these portions of my graph, I get just half of one of those parabolas. That is what your secant function looks like, but I do want to point something out. My secant function, since it's the reciprocal of cosine, I know what my cosine values are, and I know how to graph these. My cosine values, right? If I plot my cosine points, my cosine graph looks like this. And I know the cosine is not part of my secant graph, so I'm actually going to just dash it in. All right, so it is really easy to graph the secant function if I realize that my cosine function, right? If I graph my cosine function, what points do I get? If I get this point, and this point on my cosine function, I can tell that my graph has an asymptote where my cosine crosses my vertical shift. I can draw my asymptotes in very easy from where my cosine crosses my vertical shift. And then I can draw my parabolas in based off of my cosine function. Okay, so if I can graph my cosine function, then I can graph my secant function as well. All right, so here are some things that you should know about the secant function. It has a basic equation of y equals c plus a secant b times x minus d. C is the vertical shift, a is the stretch or compress factor. You calculate the period the same way you would calculate cosine, 2 pi over b, and then d is the phase shift. And again, b must be factored out or else you will not get the correct phase shift. I already mentioned the periods calculated as 2 pi over b. The way that we're going to graph our secant function is by graphing our cosine function first using a dashed line. We're going to draw asymptotes at the points where our cosine function crosses the vertical shift. I want to remind you, since secant goes all the way up and down to positive and negative infinity, it has no amplitude ever. And if it does not have a vertical shift, it will never have a x-intercept. It might have an x-intercept if you're shifting the graph up or down more than one. So let's do a couple of examples here. So the very first example that we're going to do is we're going to do y equals 2 secant 1/2 x. So again, I am going to graph my cosine function first. So I'm going to say y equals 2. I'm going to just change secant to cosine, and I'm going to graph this. So I have an amplitude for my cosine of 2. I have a period of 2 pi over 1/2, which is 4 pi. I have no vertical shift. My vertical shift is 0, and my phase shift is 0. All right, so how do those values translate to my secant function? I have a stretch of 2. I have a period of 4 pi, so our periods are the same. Cosine does have an amplitude, but my secant does not. It has a stretch by 2. My vertical shift is 0, and my phase shift is 0. So really the only difference is that cosine has the amplitude and secant does not. So how do I graph my cosine function? All right, well, I first have to label my axes. So I'm going to label my axes starting at 0. Well, we have to calculate our begin and end for cosine. Begin is going to be 1/2 x equals 0. So x equals 0. So it's going to start at 0. My end is going to be 1/2 x equals 2 pi. So x is going to be 4 pi. And we need 4 equal parts for cosine. So I'm going to count out 4. 1, 2, 3, 4. This is going to be 4 pi. So I can label each of these as 2 pi, pi, and 3 pi. I'm actually going to do 2 periods, so I'm going to go ahead and label that second period because it's very easy for me to do so. I have no vertical shift or horizontal shift, so now I'm just going to graph my cosine function in. My cosine crosses the x-axis at pi and 3 pi, the quarter and 3/4 marks. It starts off high and then goes low, and remember I have a stretch, right? I have an amplitude for my cosine of 2. So when I graph this, looks like this. So when I do the same thing on my other period, my cosine function looks like this. So now let's go ahead and draw in. The very first thing I'm going to do is draw in my asymptotes for my secant function and label them. And remember, all asymptotes must be labeled. So this is x equals negative 3 pi, x equals negative pi, x equals pi, and x equals 3 pi. All right, so now what I'm going to do is I'm going to draw in my secant function based on this. Okay, and remember secant will approach my asymptote, so I want to make sure that it does. All right, and that's how we're going to graph our secant function. So let's see if we can fit in one more example here. Or maybe I'll just start another video. I'll add another video with this example in it. All right, so watch the second video for a harder example because this one's going to be shifted. It's going to be reflected over the x-axis. Our period's no longer going to be 2 pi, and there's going to be a phase shift.